A geometric series has first term a and common ratio r. The second term of the series is 3 and the sum to infinity of the series is 16. So the second term is 3. Well, the first term is a, the second term is ar, and that equals 3. And it says the sum to infinity is 16. So that means that a over 1 minus r is equal to 16. And we're trying to show that 16r squared minus 16r plus 3 equals 0. So if we make a the subject of the first one, that would give us a equals 3 over r. And let's substitute that into the second one. So we're going to get 3 over r all over 1 minus r. That equals 16. Now, it would be easier if this wasn't a fraction on the numerator. So I'm going to times both the numerator and denominator by r. That will get rid of the r on the denominator of the numerator. Okay, so if we do that, we're going to get, well, 3 over r times r is 3. And on the denominator, if we times both of these by r, we're going to get r minus r squared, because we're going to times both of them by r. And that equals 16. And now what we're going to do is we're going to bring the r minus r squared up. So that will give us, I'm just going to go up here, 3 equals 16 bracket r minus r squared. And if we expand, we get 3 equals 16r minus 16 r squared. And then bring them all over. I'm actually going to bring them all over to the left hand side. That will give us 16r squared minus 16r plus 3 equals 0. So we have shown what we've been asked to show in question A. Part B says then find the two possible values of r. So what we're going to do is we're going to factorize this and solve it to get what the values for r would be. So factorizing it, well, if we factorize, I'm going to go for 4r and 4r, and I'm going to use minus 3 and minus 1, and that would work. Okay, so that means that r equals either 3/4 or r equals 1/4. So I found the two possible values for r. Part C says find the two possible values for a. Well, we've got this, we've got ar equals 3. So if we put r into here and the other value for r into here, we'll get our two values for a. So that will give us ar equals 3. So the first option is whenever r equals 3/4, that will give us 3/4 a equals 3. And then if we divide that by 3/4, we'll find out what a is, equals 4. So a equals 4, so that's one option. Or the other option, I'm just going to go up to the top, I'm jumping around a bit here. We've got ar equals 3, and we've got that r this time is equal to 1/4. So that means that a quarter a equals 3, so that means that a equals 12. So there are your two possible values for r, 1/4 and 3/4, and the two corresponding values for a will be then 4 and 12. Part D. Part D says should the sum Part D says should the sum Sn of the first n terms of the series is given by Sn equals 16 bracket 1 minus r to the n. So we know that Sn is equal to a bracket 1 minus r to the n, close brackets, all over 1 minus r. Notice that's quite similar to what we've got. We've got a 1 minus r to the n, but we've got the 16. And earlier on we knew that the sum to infinity was equal to 16. And the sum to infinity is a over 1 minus r. We know that's equal to 16. Well, actually, if we put these two together, if you notice we've got the a and the 1 minus r on the bottom line here. So the Sn can be rewritten. I'm just going to separate it as a over 1 minus r to the a over 1 minus r, and that times by 1 minus r to the n. So just split that up. But I know that this part's equal to 16, so Sn will equal 16 bracket 1 minus r to the n. Okay, and part E says given that r is the smaller value, so part E, we know that r is equal to 1/4. It says find the smallest value for n for which Sn exceeds 15. In other words, 16 bracket 1 minus r to the n is going to be bigger than 15. So that means we're going to have 1 minus r, well, r is equal to 1/4 in this case, 0.25, to the power of n is going to be bigger than, and if we divide the 15 by the 16, 15 divided by 16, that will give us 0.9375. So what we're going to now do is we're going to take 1 off both sides. That will be minus 0.25 to the n is bigger than Well, 0.9375 take away 1 will be minus 0.0625. I'm going to change the signs, but remember, if you change the signs in an inequality, the inequality sign turns around. So we've got 0.25 to the power of n is now going to be smaller than 0.0625. So I'm now going to take the log of both sides. So if I take the log of both sides, that would give me log of 0.25 to the power of n is smaller than the log of 0.0625. I'm going to bring the n down, so that'll be n log 0.25 is smaller than the log of 0.0625. Now we're going to divide by log 0.25. Now the log of a number less than 1 is going to be negative. So we're dividing by negative and it's an inequality. So whenever we divide here, this inequality sign will change. So it will give us n is now going to be bigger than log of 0.0625 over the log of 0.25. And whenever we work that out, we get n is bigger than 2. So that means that the question said, given that r is the smaller value, find the smallest value for n for which it exceeds 15. Well, we're just going to exceed 15, and actually if you think about it, the first term was 12 and the second term was 3. Well, it's going to be n equals 3. It will take 3 terms to exceed 15.